Where does the name object-oriented programming come from? It was first used by Alan Kay to describe the design of complex systems found in nature. He was talking about cells and multicellular organisms and how they cooperate and communicate with each other by broadcasting and receiving chemical compounds and reacting to them locally. In his great presentation, he was talking about the idea of asynchronous processing scaled up to the level of systems and scaled down to individual parallel threads and parallel processes running and talking to each other as parts of a single application. He was also the author of an object-oriented language and environment, Smalltalk, where objects followed this exact definition. He was describing actor-oriented systems. He was describing objects as things executing in parallel, acting and having local intelligence to make decisions on how to react to messages sent to them by value. These objects were also intended to have complete encapsulation of both state and function, so nobody from outside could change the state without asking the object for permission, and the processing of messages obeyed local rules. His idea was never intended to be limited to only our current synchronous understanding of objects being directly manipulated and having no autonomy about what is done to them. We were not supposed to be invoking methods on objects, rather sending requests to objects. They were intended to decide how to react themselves, change their own state, shut down or restart in case of error, in short, behave like cells of a multicellular living system. This kind of complexity and composition scales, as I mentioned, from all the way up to all the way down, from details to systems of systems. If you have ever heard about microservices, you know exactly what I'm talking about. If you have ever heard about reactive, event-driven architectures, you know exactly what I'm talking about. The fundamental distinction here is between synchronous blocking calls to directly modify an object versus asynchronous requests with by-value messages sent between objects, synchronous versus asynchronous. Here I love to mention a great post from my friend Stephen Loftus-Mercer about actor-oriented programming. The actor or microservice programming model relies on a theory that our intuitions about efficient software development are backwards. When we humans are asked to write parallel code, we feel more in control with the synchronous model, but tactically, we appear to reason more correctly under an asynchronous model. The reason for this is data changes. With asynchronous communication, only one thread is modifying any given piece of data in memory at a time. Under the synchronous model, a programmer writes a sequence of commands to change a block of data and then has to worry that between every pair of lines, the other threads could inject an infinite number of other data changes. Can the programmer really understand all of these permutations? If not, then we have bugs called race conditions, where the random and changing order of thread execution affects the success or failure of the application. Because such bugs do not reproduce easily, you have to get the same random order twice at runtime. They are among the hardest of all bugs to fix. At some point, a programmer says, "No, I need to log the data for the duration of this operation." This allows the programmer to make all the data changes without worrying about interference from other threads. But the log may prevent other threads from making any progress, leading to issues like user interfaces that hang while supposedly background tasks update. And as logs proliferate on different objects, it is easy to construct scenarios where one thread has logged half of the data, the other thread has logged the other half of the data, and neither thread can proceed with its work. We call these situations deadlocks. Finally, there is the lifetime issue. Many synchronous parallel programs have problems shutting down or finishing subroutines because it is unclear which thread actually owns the shared data and who is responsible for freeing the memory. Either the program is too aggressive and releases data before all threads are done, leading to crashes when the other threads access deallocated memory, or the program is too lax, leading to memory leaks where no one frees the memory reserved by objects. Asynchronous messaging avoids all of these issues by giving every thread its own data exclusively. The processes work on their own data. There are no references to that data for anyone else to use. The only references are the communication channels themselves. If a thread wants to tell another thread about a given value, it does not share a reference to that value. Instead, it gives the other thread its own copy of the value. Each thread knows its own status and does its own work. Ideally, even resources such as hardware are not shared. One and only one thread is responsible for addressing any given piece of hardware at a time. It may decide it's done with the hardware and give up the access, but when it does so, it can only request the access to come back, not demand it. In a synchronous model, many threads could have a reference to the same hardware at the same time and take turns using it. The proof that a synchronous programming model is superior is all around us. Besides the astronomical and exponential success of tools like Docker and Kubernetes, and the cloud proving that parallel execution and communication of small services scales and handles complex problems better, we also have increasing popularity of languages like Erlang or Elixir, which for decades implemented the actor model and are among the only ones which enable 6 to 9 nines of availability. If you don't know what that means, it just means that a system has downtime of about 1 second every 30 years. For practical purposes, this simply means that some systems written in Erlang, which has hot code swapping functionality built in, simply never go down, even if they crash, because they have an ability to recover, restart just some of their functionality, like a multi-celled organism would. I don't know about you, but for me that's very cool. Thank you all for joining me today. Please like, subscribe, and share. Provide super thanks or Patreon support if you can, and have a beautiful day. Until next time, your software minimalist.